Hello and welcome, my name's Ryan, I'm also known as RM2K Dev. Today we're going to be making an MMORPG. Now, that sounds like a big task, and it is a big task, but we're going to do it anyway. So, couple of points that I want to make before we begin, but what I'll do is I'll show you the game first. So, I've got a server here running on the left side, it's just running in debug mode at the moment, and I have two clients that are running as well. So, the first client I'm going to log in as myself, and the second client, I'm going to log in as Snake. There we go. So we have two clients currently, and as you can see, they are sharing their positional information through the server. I'll mention that this server is written in a piece of software called Node.js, and what that allows us to do is that's a real-time multi-threaded framework that can be run on a server. This server can be hosted on any Linux box. It can be scaled. There's tons and tons of tools out there that we can use with Node.js that are gonna give us much better performance than if we had made the server inside of GameMaker itself. So that's just a quick overview of our game. So you can see Snake moves, RM2K Dev moves. We're tracking their positions. We have support for multiple rooms. Pretty much, this is the bare bones of an MMORPG. And when we're done with this tutorial, you'll have a framework that you'll be able to take and turn into your own game. And hopefully along the way, I'm going to teach you how to actually do that. So I'll show you this little presentation I've made. Oops. I'm going to get rid of this game as well. And I'm just going to get rid of this console over here because that's no longer needed. And I can stop the server. Cool. So, what is it? Oh, sorry, that's slide 2. MMORPG development. What is it and what it isn't? So, what is it? We're going to be doing a client-server architecture where the client is written in GameMaker Studio and the server is written in Node.js. We will have user profiles. So as you saw, I was able to log in as a different user. We'll be having persistent data storage and the server will be real-time. So, technology overview, we're going to be using Node.js, like I said, that's a real-time server framework. It allows us to run JavaScript on the server. It's powered by Google's V8 JavaScript engine, so it's incredibly fast. We'll be using MongoDB, which is a NoSQL data storage system. So basically, it's like using MS SQL or MySQL, except that we don't need to use SQL. It's NoSQL. So we can store JSON documents into a database, and we can pull them back out using JSON queries. I'll get into all that stuff later. It's a bit technical for now, but if you don't know JSON and JavaScript and GameMaker, then maybe do some research on that stuff before you start this tutorial, because this is going to be a very complicated tutorial. Excuse me. GameMaker Studio is going to be used for our client-side engine. Main reasons that we'll be using GameMaker are simply that it runs on pretty much every platform in the planet. On the planet. It will export it out to iOS, Windows Phone. It'll run on Mac. It'll run on Linux. Your game will pretty much run anywhere. So, what it isn't. Well, it's not completed. This is just a start. It is a framework for you to take and make your own game from. We're not going to be making the next World of Warcraft here. We're just going to be making a very basic framework that you can make your own World of Warcraft in. So basically, as far as this tutorial is going to take you, it's going to get you through setting up a server, setting up a client, initiating a connection between them, handling states of objects between two clients, and also between the clients and the servers as well. And also persisting that data so that it will stay when the user logs in and out. So some final notes. No support. Well, I mean, you can read this paragraph here, but basically this is a really complicated program. And to be honest, there's a lot of different parts that we're going to be connecting together to get this to work. And if any one of those parts fails, you're probably going to have a bug in your code. So, like I said earlier, you really want to be fairly experienced at programming in not just GameMaker. You'll probably want some experience in JavaScript, if you've had experience in Microsoft.NET, any other language like that, and also using and connecting various components together, because we'll be using, I think, maybe 4 or 5 different open source third-party libraries. And like I said, if there's a bug with any of those libraries, there's probably going to be a bug in your server. So I won't be able to offer very much support in the YouTube comments for this video. However, do comment, because there is a fairly large community that's sort of grown out of these videos, and I'm sure that everyone in the community will help each other out like they've done in many of my other videos. And also, I'd also like to hear some feedback. So if you have feedback about this video and comments and feature requests and ideas of where you think I should take this, definitely let me know. And so with all of that, let's begin. So I'm here in WebStorm version 8.0.4. Version doesn't really matter, I just thought I'd share that. And in this video, we're going to be setting up our server project. So I'm going to try and keep these videos fairly short, around the 10-minute mark each, but they may vary, 10, 15 minutes, maybe 20 minutes if it's a long topic. So the first thing we're going to do, I've just got a blank folder here. I'm going to create a new JavaScript file, and I'm going to name that file server.js. My font is still pretty low. I'll just pause the video and increase the font. Okay, so server.js is going to act as the entry point to our program. We're also going to create a couple of directories. Let me just pull up some files. Here we go. So we're going to create a directory called initializers. We're going to create another directory called models. We're going to create another directory. We're going to call this one resources. Now I'll just do a brief explanation of what these mean. Basically, resources is going to be where our game data and things like that come from. Models are going to be where we model data from the database, and initializers are going to be things that we want to happen before the server starts up. So I'm just going to create another folder under our resources directory called game space data. And that's going to be where we place things like maps and items. So let's create another folder called maps and create another folder called items. This is going to be our structure. This is going to be the structure of our application. So I think the first thing that we really need to do is start working on some configuration type things. So I'm just going to open up my sample file. Here we go. So the first thing that we need to do is configuration. So under our resources directory, we're going to add a new JavaScript file. I'm going to call this one config.js. Now our config file, this is here we go. So, sorry, first thing, sorry about that. Another thing we'll do is we'll add another JSON file. If you don't have JSON file in here, you can add your own template for that. But I'm going to call this one package.json. And that's going to sit in our root directory. What I'll do with package.json is we're going to start defining some files that get imported through npm. So you will need to have Node and npm installed on your machine. There are plenty of guides online on how to do that. Just visit the Node website, Google Node, and there's literally like a downloader, and you download it and install it, and it'll be on your machine. So I'm just going to define a name for our project. It's going to be MMOSVR. I'm going to define a version. That's going to be 0.0.1. I'm going to say that it's private. I'm going to set that as true. And finally, we get down to these dependencies. So dependencies, there we go. And that's going to be a JSON object, and this is where we specify all of the third-party libraries that our server is going to use. So we're going to use minimist. Sorry, I spelled that wrong. Minimist. There we go. And the version of that, we're just going to use the latest version available. We're going to use extend. Again, we'll be using the latest version available. We need binary parser. Once again, latest version available. We need Mongoose for our database ORM, which is going to be our object relationship mapper, I think that stands for. Basically, what Mongoose does is it gives us some rich data support. It allows us to work with objects in a way where we can say user.save or I don't know, game map.load and things like that. It gives us a lot of extra functionality on top of our database objects. We're also going to need underscore. And we'll be using the latest version of that. So with all of your dependencies specified inside of our package.json file, we can open up a terminal into the folder that your server is located at and type in npm install. What that's going to do is it's going to connect to the network, download all of those libraries and stick them in a folder called node_modules. So I'm going to pause the video and I'll be back when this is completed. Okay, our npm installation is completed, and as you'll see, we have a new folder that's been created under our project called node_modules. And if I open that folder up, you'll see it has the libraries that we requested from the server. Yeah, so that is our third-party libraries set up and ready to go. So let's go back into the resources folder and go into config.js. And what we're going to do here is we're going to start specifying our game's configuration. So what I'll do is I'll create a variable called args because I want to accept incoming parameters to the application. So we use a third-party library called minimist for that, and I've imported that here using our package.json file. So I'm going to require that in using the require function, require minimist. And I'm going to pass into that minimist will return a function, so I'm going to pass that function a property, which is going to be the arguments that were supplied to the application except for the first two. So it's going to be process.argv.slice, and we're just going to get rid of the first two. Then we're going to load up our extend library. So I'm going to say var extend equals require. I'm going to require in extend. Now what extend does is it allows you to take one JavaScript object and basically copy all of the values inside of that object onto another object, therefore extending that object with the first object. So this is going to be the basis for our configuration. I need to set up my node environment now using WebStorm. If you're not using WebStorm, you don't need to do this, but you'll need to supply in the command. You'll need to supply the arguments to the program when you start it. So for instance, you'll be typing something like node into your terminal. You'll type node server.js, and you'll probably need to say --env equals test. But because we're using WebStorm, we can do that with the IDE. So I'm going to go into edit configuration. I'm going to create a new Node.js configuration. New Node.js configuration. The JavaScript file I want to run is called server.js, and the application parameters we want to pass in --env equals test. There we go. That should do it. So I'm just going to select OK. I should have named that. Sorry. Let me name that debug. Call this debug test. Now the cool thing about the way that we've done this is that you could create a new configuration, again another Node.js configuration, and we could call this one here debug prod. And in the same way that we did env last time, we could say env equals production. And I'll show you what these mean, but basically as we pass the environment into our application, we're able to use our configuration file to actually pull out some different variables. For instance, the database connectors, they will go to different places for our production server compared with our test server. So now that we've got an argument being passed to the application, let's say var environment equals args.env, because we passed the end environment into the application. Or if an environment wasn't supplied, we'll just use the test by default. So that way, if someone who doesn't know your server starts it up, it won't connect to your production database and start messing things up. It'll connect to your test database and start messing things up there. So that's our default case. So we'll give that a quick run. I'm just going to set my debug test, and I'm just going to run that application. Oh, my console needs to go back into the WebStorm. And nothing happens, obviously, because we're not doing anything yet. So I'm just going to say console.log environment. I'm just doing this to see what the environment is. So if I run my application, it should say test, and it doesn't, because we need to require the config file into our server.js file. So if we go back to server.js and say require, and it's going to be __ name, which in Node.js is the current directory of the file, plus /resources/config.js. And now when I run the application, Node will be sent server.js, server.js will require config.js, and config.js will do this, and then hopefully console log out our environment variable. Cannot find module /resource /config.js. What have I done wrong there? Sorry. Okay, I'm gonna pause the video and figure this one out. One sec. Okay, sorry about that, guys. I typed resource. It should have been resources because I've named the folder resources. And if we run that, you'll see it says test. Now, as a quick demonstration, if I were to change the environment from test to production and run the application again, you'll see the environment has now changed to production because it was passed into the application or test. So yeah, that's basic JavaScript stuff. So I hope you guys are following. Yeah, let's carry on. So now that we know our environment's working, I'm going to switch back to test. I will jump into creating some common configuration variables. I'll also add some comments because I will upload this file to GitHub or similar Bitbucket for you guys. So we'll just call this import required libraries. I think I spelled libraries wrong. It doesn't matter. And then we'll call this store the environment variable. Store the environment variable. And now we need to create our common configuration. So common config. For example, things like the name of your game, the version, max players, etc. So let's say var common _ conf equals, and we'll make this a JSON object, and it's going to store a bunch of properties. So the first property is name. We're going to call this RM2K-Devs MMO game server. The second property is going to be version. I'm going to call this version 0.0.1. The reason we store a version number, and we're not going to implement it in this test, but what you can do is you can make sure that a client is requiring a specific version of a server so that you don't have people playing your game using old versions of the client. That can help you fix bugs, and not fix bugs, that can help you avoid exploits and things like that. Now we're also going to export the environment variable. So environment is going to be environment. So basically we're saying common conf.environment is the same as the environment that we declared up here. Max players equals, I don't know, 100. Sorry, not equals, semicolon. Data _ paths. Now this is an interesting one because we need to get some data out of the server and they're always going to be in the same place. So just to save us writing out some long lines of code multiple times, I'm just storing a configuration variable in our common config for our server. So items is going to be at _ dir name plus, and now what I'm going to do is say / game data, and then I'm going to say plus items //. The only reason I've done that is so that I can just copy paste this. Bang, like that. So the next one we're going to do is maps. So our map path is going to be exactly the same as game items, except we'll just change this to maps. And finally, the starting zone for our game. So starting _ zone, and we're going to set that as rm map home. This will match to a room that we have in our game maker project. So now that our common configurations are set up, we can create our environment specific configurations. So I'm going to say var conf equals, I'm going to do a very similar thing here, except this time we'll say production, and we'll make a new variable, a new set of variables underneath that, and we'll also create one called test. Now the cool thing about this is that you can add as many different environments as you want. So for instance, if you had a version of your game that was running only for alpha testers and you wanted all the information from them to go to a different database, you could just make a new alpha test version and you would have an entire new set of configuration options for your game. That again is separate to your production and test servers. So the IP address of our production server is going to be args.ip. So that was whatever was passed into the application. So now we're able to say something like //env equals production, and then space -- IP equals 127.0.1. So we can specify the IP address of our program without having to recompile it. Or we're going to use the open IP address, which is just 0.0.0.0.0. We'll also specify the port of our application, which in our production case is going to be args for arguments.port, or we're going to use port 8081. And finally, the database we'll set up is going to be database, and that's going to be a string. This is going to be a MongoDB connection string. So I'm going to say MongoDB // just like a website. And what I'll use for this one is 127.0.0.1, so that's my local machine, / and the name of the database that you want to put it in. So I'm going to call this rm2 MMO _prod for production. Now we can copy all of this into our test setup, and we can change the variables. So test is going to run on port 8082. What this means is you can only have one server running on one port at a time. So obviously we need to have a different port for test, and this means that you're able to run your production server and your test server on the same machine, saving you resources and hopefully machine costs. The only difference being is that our database is not going to be prod, it's going to be test. And finally, what I'll do is I'll add a comment on here just to say environment specific configuration. And I may have spelt that wrong, but I don't care. So the final steps that we need to do is we need to extend all of this information from Common Conf into our production and test environments, and then we need to export the configuration. So I'm going to say extend, and the first parameter of extend is whether or not it's a deep copy. Well, it's not, so we don't need to do that. Again, I'm not going to go into too much information here about these third-party libraries. We just know that we're not going to be using a deep copy. And what we're going to be extending onto is going to be conf.production, and what we're going to be extending from is common conf, and we'll do the same for test. So now production and test share all the common variables. The final thing we need to do is export the config into our application. So I'm just going to say module.exports. It's going to be equal to config, and config is going to be equal to conf and the environment that we're using. So just to explain this line a little bit, basically we're saying to the entire application there'll be a variable available called config, and that config variable is going to be equal to conf, which is this variable here, and the environment that was specified at the very beginning of our config file, which is either test or what was passed into the application. So conf, test, and then all of these properties as well as the common properties, because they were extended onto this test object, will be available. So that's pretty much it for our config file. I'm going to jump back into our main server.js and we'll give it a quick demo. So I'm just going to say console.log, and if I say config. And you'll see that we get a whole bunch of stuff pop up. In here somewhere will be like environment from common conf and database from common conf. I'll console log out our database connector string so we can have a look what happens. So we're running this on the test environment. If I play the game, if I play the server, our database connection string is rm2k MMO test. If I change the environment to production, our database connection string is rm2 MMO prod. So you see how this allows us to change our game's configuration settings and pretty much everything about our server just by passing in a flag to the application that changes the way that it runs internally. So we don't have to create multiple versions of the project, obviously. I just noticed that this video, even though I said it's going to be 10 minutes, has now taken up 25 minutes, and that's just to get configuration up and running. So I'm going to end this video here, and I will post the next video as soon as I post this video. Thank you guys for watching. Please like my YouTube channel, or actually please like the video and subscribe to my YouTube channel, and share this video with all of your friends. And don't forget to go to the next video, because in the next video we'll be doing, don't know what we'll be doing yet, but we'll be doing the next step to our server. So thank you guys for watching. Bye.